Hey everyone, we hope you're doing well. It's been quite a week for all of us, we're quite sure. So we hope you and your families are healthy, happy, safe, and doing okay out there. So we've reached the final week of our course, and we wanted to do kind of one final snapshot that we hope you really enjoy. It's a touch longer than others, but part of that is we really care about some of these topics, and we hope this video will be quite enjoyable to extend some of our textbooks. So really quick, the last few weeks the last month or so, we've looked at kind of how to process and format data in Excel, how to do some basic kind of presentations and visualization of that work. And then today, week 11, we kind of touch on a really exciting topic of intro to programming. So what I'm going to do in this video is I'm really going to try to go a fair bit beyond our book, our textbook of these last few topics, especially programming. And so for those who have never done any programming before, this will just further the idea of introduce you to programming. And for the few computer science students we have and a few others who have done some programming before, my hope is this video will introduce you to either some people, some communities, and also a project that I'm working on that will be of interest to you and is involves some serious computation. So with that said, the page you are looking at now is, many of you probably have not heard of this, but this is a visual programming language and really a whole community called processing. I work a lot with this community. I care a lot about it, and they've become really famous because it's a great introduction to programming. It's a great language and community to introduce you to basic principles of how to program. It is also a really powerful language to build sophisticated visual type things with code, right? So I think for a lot of different people, this is a wonderful language and community to know about. So what I'm going to do really quick in just a few minutes, I'm going to introduce you to the community and the platform, and I'm just going to show you a very small, very little bit of how it works. And then I'm actually going to share one of my own projects of kind of a way of visualizing teachers and students activities in classrooms in the hopes that many of your education students, I thought you might find that really interesting, and also just give you a little taste of the things I do. And if any of you find it interesting and are still here over the next year or two, do reach out, okay? So again, this is the processing page, okay? If you search processing.org, you will get this page. Everything on this page, everything about this community is making programming free, accessible, particularly to visual artists and designers. But this is used widely in a lot of schools. So it's definitely worth knowing about. You can watch this intro video on your own time. This is a guy named Daniel Schiffman, very energetic, very awesome, very wonderful. But you can get an idea of what processing is through that. What I'll show you here is you can actually download it here. Depending on your platform. You're welcome to go do this, or you can watch what I'm going to do first, and I'll show you how it works and everything. A few other things I'll point out on the community. There's lots of instructional videos, tutorials, examples, okay? So everything up here is free content to help you learn and engage with programming, right? The one other thing I'll point out is if you click up at the top here, there's something called P5JS. All this is processing for the web, so you can actually build really cool visualizations on the web, but their commitment to equity, diversity, these other types of things is really strong across these platforms. For instance, all of this is made available in different languages, Spanish, Chinese, other types of things. I think they're expanding to 10 or so languages over the next few years is the hope. So just wanted to give you a little familiarity. Processing P5JS, same thing. One is for more desktop work, the other is for more web-based work. So what I'm going to do now, I'm just going to show you what it looks like after you download it and a few really simple things in it, okay? So after you download it, you can kind of bring it up here and you'll get a screen like this. So I'm just going to make it a touch bigger, okay? So there we go, okay? And this is kind of one way to look at this is like it's a bit beyond a text editor. It's actually called a development environment. Think of it as, well, you can't use Microsoft Word to write programs in, right? So in some of the things you're doing this week with pencil code, right? You're using something different to make those programs run. And this is a development environment to do that. You'll notice a triangle here and a square, okay? There's nothing here. It's a total blank kind of page. If we just click the triangle, it's going to run what's called the sketch. And there's nothing in it, okay? So all it runs is a little screen. You all see that there? So this is our first thing. I'm just going to show you a few things, really basics to programming, okay? So I'm going to type a few things, ignore them for a second, and then I'll explain them, right? I'm going to type void setup, parenthesis open, parenthesis closed, bracket, go down here. Oops, made a little mistake there. I'm going to stop right there, okay? Everything I just typed there, it's actually, you can kind of see it as a function. Ignore void. What does setup mean? Just kind of stop and think for a second. Setup in this case is kind of, you would stick things in here under setup that kind of set up your sketch or your drawing screen or your program, whatever, okay? So here's one thing I'm going to do. I'm going to type size 500, comma, 500, parentheses, colon. Now, for those of you who have never done programming, these parentheses and these colons are going to look kind of confusing. Think of them as like punctuation marks when you write a document, periods, these types of things, commas, okay? You can ignore them for now. They're not crucial. They're really crucial to when you're actually starting to program and write things, because if you make an error in some of these, that's important. But for now, focus. What do you think size does? And what do you think 500 and 500 mean, right? Take a second, yeah. So remember when I first ran this sketch, a screen popped up that looked kind of tiny, right? Now I've put setup, I'm going to add some things to setup, and in there I've added size, right? So hopefully you're thinking, well, maybe the size of the sketch might get a little bigger, right? And maybe it gets bigger by, what is 500 by 500? Maybe those are, well, I don't really know what those are yet, but let's run the sketch and find out, okay? Well, look at that. Our screen got a little bigger, right? Nothing too mind-blowing here, right? But can we see what we just did is we typed size, which is called kind of another function, okay? We gave it some parameters, which is an X, a width, and a Y, a height, both 500. And look at that. It made a screen that was 500 by 500, right? Now, if we change let's change the width to 1,000, right? And let's just run it again and see what happens, right? So we change the width, it gets fatter, right? Now, these are in units called pixels, this 1,500. So for those who don't know, your screen is a giant bunch of pixels, right? And it's using those as kind of measurements to draw the screen, all right? Not critical, but just want to point it out, okay? Again, if I make this 1,000 here and run again, we're going to get a big square, but a bigger screen, right? Pretty cool, okay? Nothing too mind-blowing, but let's add a few things, okay? A few more things I want to show you, all right? I'm going to type void again, and again, ignore that word. It's complicated, it's pointless, but it's really useful once you know a few more things about programming. Not important now. And then I'm going to type draw, parentheses, parentheses, and I'm going to stop there. We had a function called setup. We now have a function called draw. So setup set up our sketch, so to speak. What do you think draw might do, right? We might want to put things in there that draw stuff to the screen, right? So check this out. Instead of size, I'm going to type ellipse, parentheses. Let's go 50, comma, 50, comma, 20, comma, 20. Parentheses and a semicolon. Semicolon's like a period again, remember. Stop there for a second. Ignore all the semicolons, the parentheses. What the heck do you think ellipse means, right? Give you a second. Perhaps it means drawing something like a circle, right? And then instead of 2 parameters, 1,000 like we had for size, we have 4 parameters, 50, 50, 20, 20. If you're drawing an ellipse or a circle, what do you think you need to specify, so to speak? Perhaps like a middle point, right? Where is the circle centered on your screen? 50 and 50 are telling you that, okay? And I'll explain that when we run the sketch in a second. And what else might you need to know? Perhaps how fat and how tall the ellipse are, right? And that's what 20 and 20 are showing. So for a second, think about where is this ellipse going to be drawn in the screen sized 1,000, 1,000. And let's go find out, okay? Well, there we go. Now we have a screen, okay? And there's a little ellipse, okay? Pretty neat, right? Nothing too mind-blowing, but we get the idea. We're drawing things to the screen. And if I slide this over here, again, if you think about where the center point of that ellipse is, you can kind of start to understand 50 by 50. Well, okay, if we think of this point as 0, 0, and we know the sketch is 1,000 pixels fat or wide and 1,000 pixels tall, okay? Uh, this is drawing it at 50 pixels over here and 50 pixels down, all right? And it's drawing it 20 pixels tall and 20 pixels wide, okay? Now let's change that, right? Let's make it, I don't know, 40 pixels wide, 40 pixels tall. What should we get? Probably get a bigger ellipse, right? Pretty cool, we got a bigger ellipse, right? You can go crazy and do all sorts of things on your own time, okay? But the very last thing last two things I'm gonna show you, and then I'll transition and kind of showing a more complicated project with processing, okay? Is I'm going to change 50 and 50 to what's called a variable. It's gonna be called mouse X and mouse Y. And let's stop for a second, right? Nothing fancy. What do you think mouse X and mouse Y mean? Well, wherever your cursor is kind of, there's an XY position for your mouse. So instead of drawing an ellipse at the 50-50 point, you're going to draw it wherever your mouse is, right? Let's run it again. Pretty cool, right? Now you could draw, you could do shapes, you could do all sorts of things, right? Draw whatever you want. Wherever I move my mouse, that ellipse, another ellipse is being drawn, okay? Which raises kind of a cool point. Well, wait, how is it drawing so many ellipses, right? I thought I was just going to draw one ellipse. If we go back to our sketch, okay, this thing called draw, this function, in processing, it runs over and over and over and over again. And part of that is this is kind of like how animations are created, right? So processing is all about being able to make animated visualizations and art and visuals and these types of things, right? So this is actually what's called a loop. It runs over and over and over and over again and never stops until you end the program, until you hit that square, okay? So it just keeps drawing ellipses. Now, to make that point, the last thing I'm going to do, I'm going to add another function called background. And I'm gonna make it 0, okay? And let's just run it and see what it does, and then I'll explain. What do you think happened? Take a second. We added one function, background 0, and now not a lot of ellipses. Only one ellipse is being drawn wherever my mouse is. Pretty cool, right? But what's going on, right? Well, background, every time it loops through, okay, it draws a background with the color black. 0 actually specifies black in programming language, so to speak. It's kind of a way to label color, okay? 255 is actually white. If I change that to 255, it would draw white, okay? But in this case, we're drawing black, and then we draw the ellipse, and we do that every single time through draw. So you only are gonna see one ellipse because you draw a black background first, right? Pretty neat, okay? This may sound super basic, and for those who have done CS, okay, this is, you've done much like this before, right? So for those who haven't, okay, this should be hopefully somewhat exciting. If you go to the processing website, you'll see lots more exciting stuff, lots of tutorials, but I'm gonna switch gears completely, right? And I'm gonna show you how to build something, hopefully what you see is pretty sophisticated with this type of language, okay? Okay, so now I brought up a new sketch, also in processing, and really quick, I'm not gonna explain too much of it, but the gist is, we looked at two functions and a few little things to do to put a circle around a screen. Here's a lot more code. Don't be afraid of it. It's all just kind of language. You get used to it over time, okay? There's different ways of drawing. There's different ways of organizing it, all right? These tabs are one way that processing gives you to organize this bits of code, okay? But you get the idea. There's more code. You can kind of do different types of things, right? It's obviously a challenge to structure that code in ways that are understandable, readable, and help you do things. But I'm just going to go back here. I'm going to hit triangle, and let's run this. And so I'm running this, and right now we're seeing a screen. We do see an ellipse again going around the page, and I'll explain it in a second. So let's slow down. Again, the point here is to show you how you can use processing to build what are hopefully seen as pretty sophisticated things. In this case, what we are watching right now is a teacher's movement across a classroom over space and time. Ignore the right side for a second. On the left side, okay, is a floor plan of a classroom, right? Could be any classroom that you've been in over the years, right? So we're looking down on that space. So these are tables. The little kind of gray two circles here are people, okay? The purple line that is being produced here is the teacher's movement across an entire classroom lesson. Okay, it's kind of playing from start to finish. This lesson's about an hour long, all right? So the dot here is her position at the moment in time we're looking at, right? So in the floor plan, you can kind of see where she goes, right? And where she doesn't go. Of course, that's one big thing you can see. Now, the right view does something different. That's kind of a different type of view, and this software actually supports kind of new things, new ways to see how teachers move and talk about a classroom, as I'll show in a second. So the right view is taking all that movement on the floor plan and just dragging it across time. So if we look down here, we have a timeline in minutes and seconds from 0 to almost 56 minutes, almost an hour, right? And the teacher's movement is slowly being animated across that, right? You can see different chunks of the lesson plan. It looks like there's a lot of independent seat work towards the end of a lesson, which we're not quite there yet. I'm going to turn off the animation, right? And you get the idea that up and down in this timeline corresponds to up and down on the map. Let me clarify that a little bit better. On the timeline, I can make selections, okay? I'm going to zoom in here. I'm just taking what is 5 minutes of the teacher's movement, okay, and I'm hovering. Whenever I hover over the timeline, an ellipse is being drawn in both views, and you get the idea that this view, this timeline view, just takes all that movement on the floor plan and drags it across time, whereas vertical position corresponds with vertical position on the floor plan. So for instance, this straight line in the space-time view corresponds to where the ellipse is on the floor plan and marks about 20 seconds where the teacher is not moving, hence producing a straight line. So one of the other things I wanted to point out is as I drag my mouse, an ellipse is being drawn in both the time and on the floor plan views. And so the same principle that we just looked at, this really simple thing of how to draw an ellipse where your cursor is being applied here, just with a really different type of data set and a really different type of program. So I'll just conclude with a few other just more fun things you can do with this, since so many of us are education students. So we have this is a teacher's movement across the classroom, across the entire classroom lesson. Pretty interesting. We could ask lots of questions, hopefully together, if we were together. What do you think? How much does a teacher talk across a classroom? How would you show it, right? If I press conversation here and teacher here, all the rectangles we're seeing are turns of talk. Okay, this might make it a little clearer. When I hover over these rectangles, look at that, I can read the conversation. Again, processing allows ways to visually display text in some pretty neat ways, right? But pretty cool. We can actually say, well, we get an idea of how much a teacher is talking, and wow, we can read what the teacher is saying. We can also take all that conversation and line it up at the top of the screen, right? So that just gives us a little better idea of, kind of see how much a teacher is talking, right? We can hover across and read, of course, really quickly. We can rescale the timelines, select movement, conversation, hover in, zoom in, right? Same types of things, okay? So for folks I work with, I work with a lot of teachers, and the point is to be able to build these things in ways that allow teachers to better support them in what they're trying to do, right? And how they're trying to support students, more equitable participation patterns, more types of interactions that help students. One thing that a lot of teachers want is, well, how much are my students talking, right? Now in this case, if I turn off student conversation, I'm going to highlight student, student new, and many students, okay? And what that is highlighting is all student conversation. We can kind of highlight it up here. The differences between teacher and student conversation are pretty staggering, right? Pretty interesting. It looks like there's a really big conversation turn from a student here, right? So these are one ways to encode student categories. Obviously, these are not encoded in a way that's individual students, but all of this is being read from an Excel file, a CSV file, more or less. So things you've worked on, the data is structured in a manner that informs how it's encoded here and how it's visually displayed. So hope that roughly makes sense, right? Last thing I'm going to show, I'll turn off the conversation. What else do you think teachers would love to have in this? Give you kind of a second, okay? They'd love to have video, right? So if I click the video button here, this is from a teacher who was part of a research effort to record herself teaching. Wherever you hover and click in this timeline view, we'll play video at that point. So check it out. I'm going to click here. This is about 25 minutes into the lesson. This long straight line indicates that the teacher is not moving, okay, for a period of time. Kind of an interesting point to play, so I'll play it.
Does it go on the weather station model anywhere?
We have a teacher here working with students at this table. That's here on the floor plan, okay?
Well,
They're actually working on weather
You'll need it
maps.
to answer some questions, but you don't need it on the weather station model. Matt?
Right. pretty neat, and I can turn that off. Now, I don't know if you heard the teacher talking there. You actually do get audio, but I think in how I'm recording this, you might not hear that. So anyway, did a quick intro to processing. Hope that was neat. Hope that was fun. It's very different than pencil code. So for those who haven't experienced that, I hope you spend some time on that site. It's great. It goes way beyond what we're doing in our course, and you might really enjoy it, okay? And for then I shared a little bit on how I've applied processing and just some of the work I do with teachers, right? So I do a lot of other types of things. I'll put in my website link at the bottom in this YouTube video so you can explore some of the other things I do if of interest. And again, if you find them interesting, please do reach out. I'm new to Georgia State, would love to talk and work with a few of you. But the point of that was to kind of show you can build some pretty sophisticated things with processing. And the larger level is over the last 2 weeks, we've looked at ways of processing data, ways of presenting data in PowerPoint, and a bit on programming. We've done the basics of that, and the basics are really important. There's all sorts of things out there that you are all really capable of working and engaging with around these ideas of data processing, visualization, analysis, and programming. So I'd encourage you beyond the course to explore those things, right? So I hope this video was helpful in some way. Just try to make it a little fun. And for our discussion post this week, you'll see it. If you have any questions about processing or the visualizations I showed, please reach out. You can also ask a question about anything from the course. That's going to be kind of our final discussion post. So again, hope you're well. Looking forward to the conclusion of our course and reviewing your websites and your final project and these other things. This is our last content week. So do your very best, and we'll talk soon. We'll talk soon via announcements. All right.